Hi, this is Alex from devstories.eu. Biopython Fundamentals, Episode 17 of 18. You sequenced a gene and found a variant. Knowing the sequence is rarely enough. To understand the actual biological damage, you need to know exactly which metabolic networks the resulting enzyme disrupts. Biochemical Pathways with KEGG provides exactly that map. The Kyoto Encyclopedia of Genes and Genomes maintains extensive databases detailing biological systems, compounds, and reactions. They distribute this data as standard plain text flat files. These files use a specific structure where a keyword sits on the left margin and the associated data sits on the right. The problem is that data values, like long lists of synonyms or complex pathway names, frequently wrap unpredictably across multiple lines. Writing custom string manipulation to handle that wrapping is fragile. The bio.kegg module exists to handle the formatting quirks and translate those text files directly into predictable Python objects. To extract basic molecular data, you use the compound.parse function inside the KEGG module. You pass it an open file handle pointing to a KEGG compound text file. Instead of loading a massive database dump into memory all at once, the parser returns an iterator. Each time you advance the iterator, it yields a single Python object representing one compound. From this object, you can access the entry attribute to get the unique identifier, which typically looks like a capital C followed by numbers. Because compounds frequently have multiple common names in the literature, the name attribute returns a list of strings containing all recognized synonyms. You also get direct access to the exact molecular structure through the formula attribute. Compounds are just static materials in your system. Enzymes are what actually drive the reactions. To analyze them, you switch to the enzyme.parse function, feeding it a KEGG enzyme flat file. Just like the compound parser, it yields discrete objects one by one. You check the entry attribute to get the standard EC number and the name attribute for the enzyme designation. This is the part that matters. An enzyme does not operate in a vacuum, and the enzyme object reflects that through its pathway attribute. The parser reads the multi-line text block detailing the enzyme interactions and structures it into a clean list. Each item in that list is a tuple containing two pieces of data. The first item in the tuple is the KEGG pathway identifier, and the second is the human-readable name of that metabolic pathway. You can script a complete mapping process in just a few steps. First, you open your downloaded enzyme data file and pass it to the enzyme.parse function. You create a loop to read through the returned records. When you hit a record where the entry attribute matches the EC number of your mutated enzyme, you grab its pathway attribute. You can then iterate over that list of tuples, extracting the pathway names to immediately see if the mutation affects glycolysis, the citrate cycle, or something else entirely. The true power of the KEGG parsers is not just reading text, but converting isolated biological components into interconnected network coordinates, allowing you to trace a localized gene variant all the way to a systemic metabolic failure. If you find these episodes helpful and want to support the show, you can search for devstories.eu on Patreon. That is all for this one. Thanks for listening and keep building.